Good afternoon, Saintsman. We're live here for lesson 1.3, distance and midpoint. I, something handy that you need to make sure that you bring to class. You guys are required to get a compass, and moreover, you were instructed also to acquire a calculator, something that just came up in class. Make sure that you have both in class with you for our next class. If you attempt to complete the next quiz without the compass, you automatically actually cannot get one of the points or one of the questions. Your grade will immediately go from, if you got everything correct, you immediately go from an A to a B just by not having that one tool. So we're going to go ahead and get started here and start to define these things. So we have distance and midpoint. So we're discussing line segments. So a midpoint, simply put, the midpoint of on a segment is going to be the point that divides a segment into two congruent parts. And when we've been working, and I think you guys saw the trap in the most recent assignment, if we're working on just on a coordinate plane, vertical, horizontal line, we can use a counting principle and to find where the midpoint is. But once we get a little bit askew, that becomes far more challenging. So that's what midpoint is. Next, we're going to have what's referred to as the segment bisector, which is something that's going to achieve a midpoint when in a coordinate plane when we create it. But what it is the segment bisector is any point, line, ray, line segment, or even a plane, but we're not going to encounter that very often in this course. But it's one of those geometric things that intersects a line segment at the midpoint. So it creates two identical and congruent parts to it. So let's go ahead and actually draw that up for you real quick. Here's what this will look like. So, oops. We got a point, a line segment. I'm going to refer to this as A, B, C. So I have line line AC with B in the middle of that. And the way that we actually denote that it is congruent is with using a tick mark. We can use a single tick mark. We can use a double tick mark. This tick mark would mean that AB is congruent, which we don't write the word congruent. AB is congruent to BC. Saw some students doing that during class completing assignments, so they were congruent, not congruent. I don't know why. I mean, it's fine. It's not like it's wrong, but this is less work. So this is why we use this notation. Again, you can have a tick mark and you have two tick marks. However many corresponding tick marks we have, right? If I only have like a 2 and a 1, means these guys are not congruent. But if I have the two tick marks, these are both congruent. Therefore, AB is congruent to BC, which means that this guy, B, right here, is the midpoint. Sorry, I'm kind of writing in free space right there. All right, next. I went through grad school, and I finally, after being in graduate school, learned what absolute value means, which is a little bit embarrassing for somebody who, having the education that I have, having done as well in school as I had, but I didn't really. I mean, it's not like I didn't get the questions right on math assignments, but I really know what the true meaning of absolute value was. And what absolute value really is the distance from zero. So this is how you may have understood absolute value. For example, you would just take if you have the absolute value of 3, it's 3. And again, the absolute value of -3 is 3. And you probably just, when I was a kid, I picked it up and saw that, oh yeah, cool. You just take the number and you make it positive. And if it's positive, you keep it positive. But that's not what it really means. It means like if we're on a number line, it's that distance. So for example, let's find the distance between -6 and 2 on a number line. So rather than graphing out that number line, we can actually do the following. You can take the absolute value of -6 and add it to the absolute value of 2, because those distances, right, from 0, no matter what they are. And then we're going to have 6 is the absolute value of 6. 2 is the absolute value of 2. 6 plus 2 is equal to 8. And there we go. All right. Moving right along. Next thing that we're going to discuss here is involving the distance formula. And this is a little bit of an exercise that we're going to do to derive this formula. Um, it's a rather forgiving formula. It's going to be the one of the more significant formulas that we're going to use in the entire course. Um, this is the big challenge. I think many of you guys have handled the exercises in class so far very well, but we will have a distance formula question on your upcoming quiz. Some of you guys may have learned it previously, but we're going to spend some time with it right now. So um, here we go. Just kind of getting my um, tablet all situated here. Let's draw a coordinate plane. So I have the x and y axes within a coordinate plane. Okay. And what we're going to do is we're going to actually use a little bit of notation that you may not be familiar with yet. And we're going to relate two concepts that you may be familiar with. One of them you will be familiar with from Algebra 1, which is slope. And there's another one that you may be familiar with from just previous study, which is the Pythagorean theorem. So we're going to graph a few things here, and I'm going to use the vertical lines and the horizontal lines of the y and x axes so I can use a counting principle to actually count up the distance of my sides. Okay, so I'm going to first start by graphing this coordinate, which is the origin. The origin I'm going to label as coordinate A, point A. It is at 0, 0. Next, on the x-axis, I'm going to go over 4 spaces and give myself another coordinate here, which is going to be 4. And then I did not move up on the y-axis, so that is just going to be a 0. So this is 4, 0. And this is coordinate, actually, we're going to call this guy C, because coordinate B is going to be up 1, 2, 3 spaces. So it's x, y. So 4 right on x, and up 3 on y. And then what we have here is we have a little triangle, okay? So I'm going to connect the dots here for my triangle, okay? And for my triangle as well, I'm going to label the sides. So the side opposite the angle, like so the side opposite this angle A, which is going to be side BC, is going to be lowercase a. And then opposite B, which is side AC, right? This guy's going to be lowercase b. And then also, for naming sake, this guy over here is going to be lowercase c, opposite uppercase C. Now, few things here. This triangle is a right triangle, right? Because the we have a perpendicular intersection for line BC, okay? Just like we do for at the origin. And let's also bring up the some of these names here. So I have this side AB, which was lowercase c. I had side BC, which is lowercase a, and I have side AC, which is lowercase b, right? Line segment AB, right, is lowercase c. So this is just for naming's sake, and we're going to do a little bit with these guys in just a moment here, all right? Now, can we find the slope of this line AB right here? And of course we can. Remember that slope, we use the variable m, right? And if you remember from your Algebra 1 class, I know Mr. Isaac talks about this, slope is equal to rise over run. Oh, so much fun. The rise, which is the change in y, it's the vertical change. Well, this rise, right, is up 3. Okay? So that's going to be the numerator is going to be 3 versus my run over here is going to be the value of 4, right? We went 4 over in this. So that is 3 over 4, which we could also do, right? We could calculate this because it's the difference in my y's, okay? So the y sub 1 minus y sub 2. In other words, 3 minus 0. And then I have this as, right, at AB. And then we have this as x sub 1 minus x sub 2, right? Or 4 minus 0. Now, I want you to remember that the Pythagorean theorem states that a squared plus b squared is equal to c squared. And we're going to marry these two concepts together because remember what we have here. So rather than a, all right, a coming over here is really this, okay, which is BC, and BC is the rise. The rise, 3, really corresponds to this algebraic expression y sub 1 minus y sub 2. So I'm going to come back here and I'm going to replace a with y sub 1 minus y sub 2, and that's squared. Right? So I'm going to substitute a because this and this and this and this and this are all the same. All right. Now, b squared. That's the run. Run, right? The numerator, the denominator, which is going to be x sub 1 minus x sub 2, which was that value 4, which we had over here, which is going to be lowercase b. All right, so we're going to replace b with the run, which is x sub 1 minus x sub 2, and we're going to square that, and that's equal to c squared. Now, since I have that, this is what's kind of great about this, is algebraically speaking, I could figure out the value of c. I can get it by itself by taking a square root of this entire side. So I'm going to have y sub 1 minus y sub 2 squared plus x sub 1 minus x sub 2 squared, right? And that is all square rooted. And gentlemen, this is effectively the proof for the distance formula. So, which we've been working with in this course so far, we've been talking about segments and so forth, and we've talked about proof. And I think you guys sometimes will ask me why. You're given formulas so much. Why does this work? Why does this work? Well, the Pythagorean theorem is something that we are absolutely going to prove together later in the course because we want to get away from, as I've joked in class before, we want to get away from, trust me, bro, this just works. I think it doesn't serve you well. You need to know the logic behind what you're doing rather than just kind of blindly, smashing numbers together. So this is the explanation is why we get this formula. We could get the value of this side c. We can calculate c, right? And we know his distance. In fact, we can do that between any 2 points. We actually don't need to have it for that specific instance. It's now when we're getting away from just the horizontal and vertical movements like we had back up here, and right on AC or on BC, okay? Now, if we have something that moves, and I don't want to say at a diagonal, because a diagonal is a different thing geometrically. We're going to find out soon enough. But D is going to stand for distance, and it's a distance between any 2 coordinates. And we could even find the distance horizontally and vertically, and we're going to do that actually first and play this formula. So this is going to be y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared. And we're going to take the square root of that, and that's our distance formula. Now, students, you may be looking at this and saying, hey, Granados, you did y sub 1 minus y sub 2 and x sub 1 minus x sub 2. Well, as long as I'm consistent, as long as I go 2 minus 1 and 2 minus 1, I'm okay. And if I go 1 minus 2 and 1 minus 2, it's going to be okay. What's great too is because of the commutative property, I can do the x before the y's as well. The distance formula, as it turns out, winds up being pretty forgiving because even if I did y sub 1 and I freestyled, you can get away with it here because you square the term anyway and it winds up being positive. So, right? So if I had a negative 3 rather than a positive 3, right? 0 minus 3 or 3 minus 0, the result is going to be the opposites of each other, but when we square them, they both wind up being positive 9. So we wind up getting away with it. Here's how we employ this guy. So let's actually prove this. And I'm going to show you guys that if I did a squared plus b squared is equal to c squared. Again, this is just like when we did this in class and I gave you that algebraic example, x plus 2 is equal to 3. Yes, you already have the answer in mind, but I want to be able to demonstrate this to you where you already know what your answer is going to be. And then for a more simple example, and that way when we add some complexity to it, the more complex methodology we can trust works. So a squared plus b squared is equal to c squared. We have 3 squared, right? Plus 4 squared. Going back here, right? Because our rise over our run, our a was 3, right? Our b was 4. and that was equal to c squared, right? Whatever that is. So 9 plus 16 is equal to c squared, or 25 is equal to c squared. And then the way that we get c by itself is we have to take a square root of both sides, okay? And then I'm going to wind up with 5 being equal to c. Now, I'm not worried about being plus or minus 5 because that's typically what we do here, the inverse operation. But the plus minus is irrelevant because we're solving for the length of a side, and we can't have a negative side length for a triangle. It's nonsense, right? It just seems kind of silly. We don't even know what that would be, like inside out or something. I don't know. Now we will deal with negative distances, but not yet, not in this course. We won't deal with negative measurements for a side, but when we do get to, when you study physics, you'll talk about negative distance. That's going to come up then. Okay, so here we go. Let's actually employ this here and relate this to the distance formula as it pertains to the coordinate plane. So A was 0, 0, B was 4, comma 3, and C was 4, comma 0, right? So we're going to find AB. Okay, and here's your hint. You know what you're really looking for? This is going to be the same thing as C. It's going to be equal to C in the end, wasn't it? When we went back up here, AB, right? Okay, so watch this. Let's use the distance formula. We already know our answer is going to be 5. Now watch how this works out, okay? Just so we have it in mind and know that when if we don't get 5, then we messed up in doing our distance formula. We royally screwed up. So big square root, okay? And then I'm going to go over here to my A and my B, and I'm going to label these guys, and I'm going to name them. So this is going to be my X sub 1. This is going to be my X sub 2. This is going to be my Y sub. Oops, that's wrong. Now, you guys see why? I had 0, 0, X sub 1, X sub 2. Guys, that's not how it works. This is X comma Y, so this is X sub 1, Y sub 1. And then 4, 3, this is X sub 2, and this is Y sub 2. Now, these are subscripts. These are not powers. This doesn't have a mathematical function. And when I say sub, it's a subscript. All this means is it's like X the first and X the second. First X, second X. For example, my name, Esteban Granados the third. That's because there's, the different guys got the same name. So to differentiate, right, I would get a subscript of 3, but instead we give a suffix, right? My son has the fourth. You technically, I guess, have a that's kind of a funny thing. I'm giving him a suffix, a subscript for his suffix. Anyhow, so let's go ahead and substitute now. So we have our Y sub 2, right? And we're going to go big square root. So Y sub 2, which is 0, minus Y sub 1. I'm sorry, guys. Y sub 2, which is 3. It's this guy. My apologies. And we could have put 0. We could have gone 0 minus 3 or 3 minus 0. We just talked about that. We're going to square that in the end. And then we're going to have X sub 2, which is 4. And that's going to be minus 0. And that's going to be squared as well. Yeah, kind of funny because it should be illustrating exactly what I was saying. If I did 0 minus 3, it would have gotten me negative 3. But what I wind up doing is I have 3 minus 0, which is 3 anyway, right? Square it is going to be 9. Negative 3 squared would have been 9 anyway. 4 minus 0 is 4. Squared is 16. Square root of 9 plus 16 is 25. Rad 25 is equal to, as we already knew we did in the first place, 5. Okay. I've got a few more examples for you. One more for distance, okay? And then we're going to do some stuff with midpoint. All right, so our next thing, we're going to find the distance between E, which is negative 4 comma 1, and F, which is 3 comma negative 1. How do we do it? Well, here we go. Let's use our distance formula. Remember, D is equal to big square root, right? Y sub 2 minus Y sub 1 squared plus X sub 2 minus X sub 1 squared. Okay, let's label our points. And as soon as I label this guy right here, everything else will have a name. So this guy I'm going to call, this guy will be, it's X comma Y, so this will be X. He'll be the first X, right? So this is X sub 1. So it's got to be comma y. And this has to be the first y since this guy's also the first x. We never freestyle. It wouldn't be x sub 1, y sub 2. That's crazy. Okay, so f, we have 3. This guy's going to be x sub 2. And negative 1 is going to be y sub 2. Okay, big square root. And now we substitute. We have negative 1, right, for y sub 2, minus 4 squared. Okay. Oh, goodness gracious. You guys are looking at this and thinking Granados. You're crazy. It's negative 1. Sorry. That's my y sub 1. Minus 1 squared. And then my x sub 2 plus 3 minus 4, right? Which would make this positive. Minus makes it positive. And then my negative 1 minus 1 is negative 2. That's going to get squared, right? And then I have my 3 plus 4, which is going to give me 7, and that's going to be squared. Negative 2 squared is 4. Negative 7, or positive 7 squared is 49, right? 7 times 7. 4, so square root of 4 plus 9, which is rad 53. We say this as rad 53, okay? Please, gentlemen, I'm going to make us be emphatic about this next point, okay? Please leave as a radical. Do not give a decimal answer. I don't care. I will not be impressed that you can punch square root of 53 into a calculator and then spit out, right, that this thing is 7 point blah, 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 blah. I don't care. All right. The most accurate version of that answer is rad 53. Why do more work? I'm asking you to leave it as this. This is the exact answer, and that's what we're after here in mathematics. I'll give you guys a little bit more on that in class. And we'll talk about the Pythagoreans and why we have radicals in the first place. Okay, midpoint formula. Oops. Man. There we go. The midpoint formula. Pretty straightforward. You're going to take the average of the x's, comma, the average of the y's. Now, it's just kind of a funny thing because we're going to take an average between two things. In other words, we take both x's, we add them together, and then we divide by 2, and then we take both y's and we add them together, and we divide by 2. And that gives us the midpoint. So, our next exercise, we're going to find the midpoint. Of, for AB, if A is 2 comma negative 3, and B is 9 comma 0. Okay. So let's use our formula. Oops. Here we go. Let's label these guys. This is x sub 1. This is y sub 1. This is x sub 2. This is y sub 2. So then, in parentheses, I'm going to add my x's together. So I have 2 plus 9, right? X plus x, all over 2. And I'm going to add my y's, right? Negative 3 plus 0 over 2. Okay? And then I'm going to have improper fractions. I have 11 over 2, comma, negative 3 over 2. Gentlemen, you can just leave this guy like this. That's your midpoint. If you want to write this guy as a mixed number, you're welcome to. I don't need it, though. I mean, I'm cool with you leaving. Both answers are correct. I'm cool with you leaving it just like this, though. Why take the extra step? Okay. Last example for today. We're going to do kind of a complex problem here. And where we're going to use and kind of do the midpoint, I want to say backwards, but we're going to have one of the points that's not the midpoint as our unknown. So we're going to find D. If E is the midpoint of DF and E is equal to negative 6 comma 4, and f is negative 5 comma negative 3. All right. Um, so here we go. Let's see what this looks like. Okay. E is the midpoint of DF. So I'm going to draw this. You don't have to, but this helps me to actually give this some sort of, make some sense of this. So I have D, I have E, and I have F here. Okay. E is between D and F. Now let me actually mark this guy. So this guy E is going to be negative 6 comma 4. F is negative 5 comma negative 3. And then this guy D is what I don't know, X comma Y. All right. So if E is the midpoint, then what I know is that E is going to be, and I'm going to leave myself some room here where I have negative 6 comma positive 4. Now, guys, this is what I'm saying here is that take a look at this thing. This is kind of written in a funky way. Now, think about, like, go back to your distance, your midpoint formula, x sub 2, x sub 1 plus x sub 2 over 2. Well, here we have our x sub 1 and our y sub 1. And then this guy is effectively my x sub 2 and my y sub 2. So this guy's equal to, right, negative 5 plus x sub 2, or just x, over 2. And this guy's equal to negative 3 plus y over 2. And then now we can just solve each of these things. I'm going to make two different problems here, all right? I'm going to have negative 6, which is equal to negative 5 plus x over 2. And I'm going to solve this. I have positive 4, which is equal to negative 3 plus y over 2. Okay? And then let's go ahead and operate here. And multiply by 2 on both sides. I have negative 12 now, which is equal to, those guys factor out, negative 5 plus x. And then I'm going to add 5 to both sides. These guys cancel out. So I have negative 12 plus 5, which is negative 7. And that's equal to x. Okay? And then on the other side, multiply by 2 on both sides. So this guy factors out. 2 times 4 is 8, which is equal to negative 3 plus y. And then I'm going to add 3 to both sides. Negative 3 cancels. 8 plus 3 is 11. That's my y. And of course, my coordinate is x comma y. So d effectively is negative 7 comma 11. X comma y. And there we go. Good luck, and I will see you guys in class.